Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we're going to talk about the Windows Phone emulator. And we've seen it already at work in this series several times and how crucial it's become to developing apps for the Windows Phone platform. So what I wanted to do was spend a little more time, become familiar with it, and then point you to some additional resources and give you some direction for more information after this lesson. So our game plan in this lesson is, first of all, we're going to talk about what exactly the Windows Phone emulator is, and we're going to talk about how it supplies different versions of the emulator for different deployment scenarios to kind of give you some options for the different types of phones that you might see on the market. Some with a lot of memory, some with little memory, some with large screens, some with small screens, and so on. Then we're going to learn about the function of the emulator, including the keyboard shortcuts that emulate the actual buttons, physical buttons on the side of the device. And then third, we're going to learn about the controls of the emulator that allow you to resize it on screen, to rotate it, to simulate the act of handling the virtual device as if it were a physical one, to shake it and things of that nature, how to get accelerometer and GPS support, and so on. Okay, so let's start by talking about what exactly is the Windows Phone emulator. Well, in a nutshell, the Windows Phone emulator is a desktop application, like you see here, and it actually provides similar performance to the physical Windows Phone device. It provides a virtualized environment in which you can debug and test Windows Phone apps without having to have a physical device or deploying to the physical device every single time that you want to just test some small feature that you've added to your app. And like I said at the very outset of this series of lessons, you get the Windows Phone emulator when you install the Windows Phone 8 API, and we had to make some special changes potentially to our BIOS settings in order that it could run Microsoft's Hyper-V. And we talked about what Hyper-V was, and basically we're running a whole operating system as a small application inside of our larger operating system running Windows 8. And so that's why we need Microsoft's Hyper-V installed on our computer that we're going to be doing development on. And so for a more friendly introduction to Hyper-V on Windows 8, you want to check out this blog post from the Windows 8 team. I found it to be pretty valuable. Bringing Hyper-V to Windows 8. Just some good background information. So while the emulator is great for development and quick debugging sessions, before you publish your app to the Windows Phone store, Microsoft recommends that you actually test your app on a real phone. So make sure you heed that, and you'll want to have at least one phone, if not more, available to you if you're serious about app development. Okay, so let's do this. Let's stop the emulator from running right now. And you know, when we were working through these examples, up to now we clicked the little Run Debug button on Visual Studio's toolbar, and we just left this default emulator, WVGA 512 megabyte, right? So what exactly does that WVGA 512 megabyte really mean? Well, the 512 MB or megabyte part indicates that we're running in a memory-constrained environment. The default emulator image that we use by default in Visual Studio is the emulator WVGA 512, which emulates a memory-constrained Windows Phone 8 phone. So for example, the Lumia 610 is an inexpensive entry-level Windows Phone 8 device which sports only 256 megabytes of RAM. By contrast, the phone that I had, the Lumia 920, has 1 gig of RAM. So on lower RAM devices, having multiple apps running at the same time or creating a memory-intensive app could cause performance problems. So to be sure that your app will run well on lower RAM devices, you can test your app using a realistic emulator image. And there are a number of great articles about RAM usage on the phone on MSDN. So let me point you out to just a couple that I found valuable as I was preparing for this series of lessons. The first one is App Performance Considerations for Windows Phone. And then the second one is optimizing apps for lower cost devices. You'll definitely want to pay attention to these as you're building your apps to make sure that you're accounting for all the different potential consumers of your app. So we talked about the 512 and how that might be a memory constrained version of the emulator. What does this WVGA mean? What is that an acronym for? Well, the emulator allows you to test your app on on a unique emulator image for each of the screen resolutions that are supported by Windows Phone. So this default selection, WVGA, encourages you to target the largest possible market for your Windows Phone 8 app. And if we were to drop down this little arrow, you can see that there are a number of additional options here. There's the WVGA WXGA, which is 1280 by 768, which is the largest resolution, and then this Emulator 720p, which is it's like a high def resolution, and it's close in size to the WXGA. The orientation is just a little bit different. If you run the default, then go to the Settings app in the About button, and you can see that confirmed. So let's go ahead and just run this here. And we'll go to here, and we'll go to Settings. Whoops. Settings. If you go to the About near the bottom, you can see that this particular one is running at a resolution of 480 by 800, which again is the WVGA. It tells you the operating system and all that kind of stuff as well. All right. So how does this translate into the actual phones that are on the market right now? Well, I already told you about the Lumia 920. It has a display size of 4.5 inches wide at its, diagonally. And then the display resolution is the WXGA, the 1280 by 768. The Lumia 820 has a slightly smaller display size at 4.3 inches, and its display resolution is WVGA, the 800 by 480. And then, like I mentioned just a moment ago, the Lumia 610 has a display size of 3.7 inches, so considerably smaller, and there you find the WVGA, the 800 by 480. So I realize by the time that you watch this video, there might be newer phones on the market. The point is that you should be aware of the fact that you're going to need to support different screen resolutions and memory constraints. Like I talked about in the lesson on laying out XAML, you want to eliminate specific pixel sizes for layout, except for margins and things like that. So choosing from the different emulator sizes can make sure that you're on the right track and that your app's going to look good no matter which phone your consumer potentially has. All right? All right, so now let's talk about the special features of the Windows Phone emulator. Let me move it over here a little bit. I'll not spend a lot of time on the phone's basic navigation. I mean, if you've already got a physical phone or if you play around with this one, you can see there's basically two screens. There's this start page where you pin apps to, and then there's the app page where you can find all the apps that are installed on the phone. And essentially, by using the emulator, you're going to have an identical experience, or at least almost identical experience. Complete with the start and the apps page. You have search, and you can do web browsing and things of that nature. There'll be the clock and the battery in the upper right-hand corner. And so when I actually got my first Windows Phone device, I already was pretty much familiar with the navigation of it because I'd worked so much with the emulator. Very, very similar. So you actually have the same hardware buttons on the bottom of the emulator as you would have on a real Windows Phone. However, you're going to be missing the buttons on, like I said, the side of the phone here. For example, my Lumia 920 has 3 buttons on the side. It has a volume up-down button, it has a power button, and then also at the bottom it has a camera button. And these can be accessed in the emulator with keyboard function keys. And so there's a great list of keyboard mappings here, as you can see on this web page from MSDN. But essentially, there are a number that you should be familiar with, depending on the type of app that you're building. Like, for example, if you're building a photo or pictures app, you'd want to become familiar with the F6 and the F7 button for the camera halfway down, which will start the initialize the flash feature, or F7 to take a picture by pushing the button completely down. The F9 and F10 raise and lower the volumes respectively of the sound on the phone. F11 plays or pauses the audio that's currently playing on the phone. It simulates an inline headphone button that pauses music and answers incoming phone calls. So if you double tap the button, it'll skip to the next track on your playlist or your album. Okay, and then the F12 key is the power button or the lock screen, so that you can, act like you're shutting the phone down, or at least getting out of the of a given app. And then F1, F2, and F3 simulate the bottom buttons on the face of the phone. So the back button, the Windows key, and the search button respectively. All right, so let's talk about working with the emulator keyboard. Let's do this. I'm going to hit the search button. And then if you were to put your mouse cursor in the area where you would search for something in Bing.com, you'll see the keyboard pops up. And I can use my mouse to simulate typing the keys. For example, if I wanted to start typing, it obviously takes a little bit of time to hunt and peck around. And what I can do is eliminate this keyboard by using the page down key on my keyboard. So for example here you can see I remove the keyboard and now I can just type on my actual physical keyboard hooked up to my computer. And there's also the page up button which will show the keyboard again, and then there's a pause or break button that toggles the keyboard, so you could just use that all the time. So as you can see, I typed in the phrase Selfridge, Chicago, looking for articles or a Wikipedia article on one of Chicago's most famous sons, Harry Selfridge, who founded the retail store Selfridges of London and is also the subject of a popular TV show on the BBC. So when I clicked the Go button on the little keyboard, Bing Search works in the emulator just as it would on a physical device. It will, if it's the first time that you run it, it'll ask for permission to use your location in case that would influence the search results. For example, if I was in London while searching for this, Bing might show me a map of the Selfridges that are near me where I'm physically standing in London. However, since I'm in the USA, Bing will deliver different results. And I'm going to show you how the emulator determines this location in just a moment. But at any rate, you can see that we get, a Wikipedia article and some additional content from our search. In addition to the virtualized phone on screen, there's a floating menu off to the right-hand side that we kind of ignored up to now. But it, with a little experimentation, will reveal that the first 6 buttons are in order. This X button will shut down the emulator. The minus button will minimize it to the Windows taskbar. You can rotate the emulator 90 degrees counterclockwise or rotate it clockwise, and you can see the animation as you do that. All right. There we go. And this button will expand the emulator to fit the largest size that it can fit comfortably on your computer screen. And then this button here will actually bring up the little zoom dialog, which will allow you to choose from some preset sizes to zoom in for the size of the emulator on your computer screen. This little double chevron over here to the right hand side will open up this additional tools dialog, and this is where we're going to spend the majority of the rest of this lesson. There are a number of tabs across the top of the screen. There's accelerometer, location, screenshot, and network. The first is the accelerometer, which can be used to test apps that utilize the accelerometer sensor within the phone. So what you can do is just like pull this little button down and it simulates the changing of the X, Y, and Z position of the phone in 3D space. All right, so that's essentially what we're doing when we're pulling it like this or pushing it forward. We're moving it back and forth, right? You can also change the orientation, like whether it's up this way or flat down by changing these orientations. And then there's also recorded data. So for example, you can see what will happen if we try to shake the phone, and you can see those pre-recorded values were going wild because it's simulating the fact of somebody doing this with their phone. Very cool. All right, let's get this back oriented correctly. There we go. So the next tab I found the most interesting. It's the location tab, which allows you to set the current location of the phone. So even though I'm sitting in Dallas, Texas right now, I can act like my phone is, that I'm testing my phone in Chicago or any other place in the world. But notice by default that it's going to go to Seattle, all right? So a little nod to the gentleman in Redmond that actually built the phone. So if I wanted to change this location, I can type in Chicago, Illinois, and then hit the search or the enter key on my keyboard. You can see that it brings up a map of Chicago. I can use my mouse button to set a specific location. I can also zoom in and zoom out. But now when I click somewhere in Chicago to add a marker, you can see that it will give me the exact latitude and longitude coordinates for that marker. The neat thing is once I make that change, I can go back over here to my apps, and if I find the map app on the phone and it says, will you allow maps to access and use your location? Okay. The phone now thinks it's moved across the country from Seattle to Chicago, and you can see we're here in Cicero neighborhood near where I grew up. Okay, very cool. And then let's move on now. The third tab is for creating screenshots. So this can be helpful whenever you're creating documentation or whenever you're trying to document bugs in your app and you want to upload them somehow. They're also useful when you're submitting your app to the store because you're going to need so many screenshots at different resolutions. And then the final tab is the network tab. And there's not a lot you can do here other than to see the IP address of the phone on your network. Okay, so in addition to the emulator itself, let's go ahead and shut this down. Visual Studio has some tooling that can affect how the XAML designer displays the phone, how it displays the orientation, the theme color, and the chrome around it here in the XAML editor. And so the first thing that you can do is go to this device window off to the left-hand side, and you can see that you can change, for example, the orientation, the display size, the theme, the accent color, whether or not to show the chrome around the device. And now we see we've gotten rid of all of that just by unchecking that check mark and so on. And we can also make it large enough so that it fits whatever window resolution we've assigned to it. So let's go ahead and undo that. There's also a simulation dashboard. So if you take a look at this little button that's next to the supported platforms dropdown, the simulation dashboard pops open here kind of on top of your Solution Explorer. And I'm going to have to make some room here so you can see it nicely. The simulation dashboard gives you the ability to simulate different network conditions, like if you wanted to throttle the speed of the network and then test how your app will perform when it has almost no network or just Wi-Fi speeds, or you want to change the signal strength and see how that impacts your app. You can do that here. You can also lock or unlock the lock screen and trigger reminders for the purpose of as we'll see a little bit later on the lock screen itself. Okay? So basically you have many ways to test and monitor your app during development time so you can gain some confidence in how it will perform once you distribute it to the store. Alright, so let's recap. Well, one last thing. It's okay to leave the emulator up and running even when you're actually developing here and you're writing code. You don't have to shut it down every single time. When you relaunch your app in debug mode from Visual Studio, part of the process is deploying the latest version of the app to the phone. It's time consuming to relaunch the emulator every single time you want to do that, and Visual Studio will connect to an existing emulator instance whenever it needs to. So to recap, the emulator is a great tool that allows you to quickly deploy your app during development to a virtualized Windows phone. We looked at how to test different device sizes and memory constraints, how to manipulate the emulator to test for rotation and motion, how to make the phone think that it's located geographically in a specific place, and a bunch of other cool little options and things that you can use as well. We're going to use these skills extensively throughout the rest of this series, so hopefully you're paying attention. All right, that wraps it up. We'll keep going in the next lesson. See you there. Thank you.